If an alien civilization ever made contact with Earth, you probably imagine a dramatic moment, a massive ship above a city, a message on every screen. But that's not how it would happen. The first sign would be quiet, almost invisible. A tiny anomaly in a dataset that 99% of the world would never hear about. And from there, things would escalate, slowly at first, then all at once. This is every level of alien contact. And the science says each one is more plausible than you think. You are a radio astronomer on a night shift at a facility in the desert. The telescope is running its usual sweep, scanning a narrow slice of the sky at 1420 megahertz. The hydrogen line, the most common frequency in the universe. If something intelligent wanted to send a message, this is the channel it would use. The computer flags something, a narrowband signal, strong, too strong to be background noise. It lasts for about 70 seconds and then it's gone. You've seen this before. It's always interference, a satellite, a microwave oven in the break room, a military radar bouncing off the atmosphere. You check the logs, nothing matches. You check the frequency. It sits right on the hydrogen line, not drifting, not broadband, not behaving like anything natural. Your pulse doesn't change, not yet. You've been trained for this. The IAA post-detection protocol says, verify first. Tell no one until you're sure. Contact a second observatory and ask them to point their telescope at the same patch of sky. Rule out everything human. Rule out everything natural. Only then, only when every other explanation has been eliminated, do you even consider the word. You send the request. You don't say why. You just give them the coordinates and the frequency. Then you sit back. The screen is quiet. The desert outside is dark. In 1977, an astronomer named Jerry Ehman found a signal exactly like this. 72 seconds, right on the hydrogen line, 30 times louder than the background. He wrote one word in the margin of the printout. Wow! It never came back. The second observatory confirms it within 6 hours. A radio telescope in South Africa, the Meerkat Array, 64 dishes aimed at the same coordinates. They see the same thing, same frequency, same structure, same impossible narrowband spike sitting right on the hydrogen line. Then, a third confirmation. The FAST telescope in China, 500 meters across, the largest single dish on Earth. Same signal. No drift consistent with a satellite, no match to any known spacecraft, military transmission, or natural source. You are now part of a group of 11 people who know this is real. The IAA protocol is clear. No public announcement until verification is complete. No premature disclosure. You follow the rules. You document everything. You prepare a formal report for the International Astronomical Union. But the rules were written before the internet. Someone in the chain, you never find out who, posts a screenshot of the signal data on a forum. Within hours, it's on every platform on Earth. The headlines are wrong. They say things like alien message received and first contact confirmed. Neither is true, not yet. All you have is a signal that isn't natural and isn't human. That's it. The official Rio scale score is calculated at 8. Extraordinary. 3 independent observatories, 3 confirmations, no natural or human explanation. The math says this is real. The media doesn't report the number. The number isn't dramatic enough. They just want the word alien. Governments begin calling, not to help, to control. Who responds? Who speaks for humanity? The protocol says no reply without broad international consensus, coordinated through the United Nations. But the protocol is a voluntary agreement. It carries no legal force. And sending a targeted signal across light years of space requires serious hardware. A planetary radar like NASA's Deep Space Network or China's FAST. Only a handful of facilities on Earth can do it. Any government, any agency, any tech billionaire who rents time on a deep space transmitter could answer on behalf of the entire species. No one answers, not yet. But the argument over who should answer has already begun. The signal has structure. At first, it looked like a repeating pulse, A narrow spike, on-off, evenly spaced. But when your team maps the timing intervals, a pattern appears. The gaps between pulses encode numbers: 2, 3, 5, 7, 11, 13, prime numbers. The sequence no star produces, no pulsar mimics, no random process generates. Primes are the mathematical fingerprint of a mind, anywhere in the universe, that has learned to count and divide. This is the part the scientists expected. The textbooks predicted it. If an intelligence wants to prove it exists, it sends primes. They're the handshake. The "we are here and we are thinking." But the primes stop after 97. And what follows is not in the textbooks. The signal shifts. The pulses become denser, faster, layered. Binary data, ones and zeros, streaming in blocks. Each block is exactly 1,679 bits long. That number is the product of two primes, 23 and 73. Arrange the bits into a grid of 23 columns and 73 rows, and an image appears. Your team stares at it for hours. It's not a face, it's not a map. It's a diagram of a hydrogen atom, the same atom whose emission frequency carried the signal here. Then a second image, a diagram of a carbon atom, then oxygen, then a long molecular chain that no one on your team can identify. The data keeps coming, weeks of it. The Rio scale score is revised upward from 8 to 10, the maximum. The word extraordinary doesn't feel like enough anymore. A formal report is filed with the United Nations Secretary General, exactly as the IAA protocol requires. But the protocol was designed for a signal. This isn't a signal anymore. This is a curriculum. Someone is teaching you something, and you don't know why. The data contains no coordinates, no return address, no instructions for how to reply. Just information, streaming steadily like a lecture delivered to an empty room. Or maybe not empty. Maybe they know exactly who's listening. The decoded data contains a star map, not a map of a galaxy. A hyper-detailed map of the local stellar neighborhood. Every star within 20 light-years of the Sun, plotted with coordinates more precise than any human catalogue. And right in the center, marked and annotated, is your star, your Sun. Whoever sent this hasn't just looked at your sky. They've mapped your exact position. Buried in the map is a second marker, a single point highlighted. A star 12 light-years away. Close, cosmically speaking. Close enough that its light left the surface while you were still in school. Astronomers turn every available instrument toward it. Optical telescopes, infrared surveys. The James Webb Space Telescope shifted its schedule within 48 hours, an unprecedented priority override. What they find doesn't make sense. The star's visible light output is normal, but in the mid-infrared, it's too bright. Roughly 60 times more infrared radiation than a star of that size and age should produce. Something around that star is absorbing visible light and re-emitting it as heat. Something enormous. In 2024, Project Hephaestus, a real search program, scanned 5 million stars looking for exactly this signature. They found 7 candidates, faint, ambiguous, possibly natural. This is not ambiguous. This is a star wrapped in something artificial on a scale that dwarfs every structure humanity has ever built. A Kardashev Type II civilization, one that harnesses the energy of its entire star, would look exactly like this. Earth's total energy consumption is roughly 18 terawatts. This structure is capturing something in the range of 10 to the 26th power watts. That's not 1,000,000 times more than us. It's 10 trillion times more. The data stream suddenly makes more sense. The molecular diagrams, the chemistry, it was never a greeting, it was a specification sheet. They were telling you what they can build. And the signal was not aimed at Earth. Triangulation of the original transmission reveals the beam was pointed somewhere else, toward a second star farther out. You didn't receive a message, you intercepted one. 2 civilizations were already talking. You just happen to be listening. The signal stops. Not a gradual fade, not a slow decay into noise. 1 second it's there, a steady stream of data, precise and unbroken, and the next second, nothing, like a hand pulling a plug. Every radio telescope on Earth confirms it within minutes. The frequency is clear, the hydrogen line is empty, the star is still there, the infrared excess is still there, but the voice is gone. You check the equipment, you check the software, you check everything you can check from 12 light-years away, which is almost nothing. There is no way to know what happened. Did they choose to stop? Did they finish what they were sending? Or did something stop them? The world splits into 2 camps. The optimists say the transmission was complete, a finite message delivered in full, now waiting to be studied. The pessimists say something else. They point to a physicist named Enrico Fermi, who in 1950 asked the simplest and most terrifying question in the history of science. Where is everybody? The universe is 13.8 billion years old. There are hundreds of billions of galaxies, each containing hundreds of billions of stars. The math says intelligent life should be everywhere, but in 60 years of searching, we found nothing until now. And now, the one signal we did find just went silent. The dark forest hypothesis enters the news cycle. The idea, rooted in game theory and named after a 2008 novel by Liu Cixin, is simple. The universe is full of civilizations. They are all quiet. Because the ones that made noise are no longer here. In a dark forest, every civilization is a hunter. You don't call out, you don't light a fire, because you don't know who's listening, and neither did they. The question no one wants to ask, did we just watch a civilization die? Or worse, did they die 12 years ago, and the light is only reaching us now? 3 years after the signal stops, an astronomer mapping the outer solar system notices something wrong. An object in the Oort cloud, the vast shell of ice and debris that surrounds our solar system at roughly a light-year's distance, is moving. Not drifting, moving with purpose. It has changed trajectory twice in 6 months, each correction too precise to be gravitational. The object is small, maybe 10 meters across. It has no visible propulsion. It reflects almost no light. If the astronomer hadn't been running a new infrared survey of that exact region, it would never have been found. It is heading inward, toward the sun, toward us. In 1960, a radio astronomer named Ronald Bracewell proposed an idea. Instead of sending radio signals across the galaxy, slow, weak, easy to miss, an advanced civilization might send physical probes. Autonomous machines, loaded with artificial intelligence, launched at modest speeds toward promising star systems. They wouldn't need to travel fast. They could take thousands of years to arrive. And once there, they would wait. Dormant, patient. Earth's first radio transmissions leaked into space in the 1930s. If a Bracewell probe had been sitting in the Oort cloud this entire time, it would have heard us decades ago. But it didn't move. It wasn't listening for us. It was waiting for an order from home. The signal from levels 1 through 3, the primes, the binary, the chemistry, wasn't a lesson. It was an activation code, and something in our solar system received it. Now it's moving. The object doesn't respond to any transmission aimed at it. It emits no signal. It simply falls inward, decelerating in ways that suggest an internal power source expending energy to slow down. Within 18 months, it enters the inner solar system. Telescopes track it past the orbit of Jupiter, then Mars. It settles into a stable orbit between Earth and the Moon. And it does nothing. It just watches. A machine older than human civilization, parked on our doorstep, running on instructions from a species that may no longer exist, or a species that knows exactly what it's doing. The probe is not alone. 6 weeks after the first object settles into its orbit, a second is detected, then a third, then 11 more. They emerge from different vectors, some from the Oort cloud, some from trajectories that suggest they entered the solar system decades ago and have been coasting silently inward ever since. 14 identical objects, same size, same lack of reflectivity, same silent refusal to respond. They take up positions in orbit around Earth, the Moon and Mars. Evenly spaced, geometrically precise, a network. The military labels them. Each gets a designation. Tracking stations assign orbits. Interceptor missions are proposed, debated and stalled. No government wants to be the one that touches the first alien artifact in human history and triggers something irreversible. The probes do not communicate with Earth, but they communicate with each other. Short encrypted bursts in a frequency band no human transmitter uses, detected only because a graduate student at MIT happens to be calibrating a new receiver at the right time. The bursts are tightly directional, probe to probe, a closed network, running a protocol that no one on Earth can read. And then the network does something new. The probes begin transmitting outward, not toward the star they came from, not toward anything in the original signal's path, toward open space, in every direction. A broadband pulse repeated every 90 seconds, carrying what appears to be a compressed data package. Your team decodes part of it, coordinates, spectral data, atmospheric composition, a complete technical profile of Earth, its location, its chemistry, its electromagnetic signature, everything a distant observer would need to find us. Earth's radio bubble extends roughly 120 light-years into space. Faint, diffuse, easy to miss. What the probes are sending is not faint. It is a focused, high-energy beacon broadcasting our exact position into the galaxy with a clarity our own signals never had. The probes were not sent to observe, they were sent to confirm. And now they are telling everyone where we are. The math takes less than a day to finish. The answer takes longer to accept. The probe's outward transmission is powerful, orders of magnitude stronger than anything Earth has ever broadcast. If there is anything within 1,000 light-years capable of detecting an artificial signal, it now knows exactly where you are. The message is already traveling. It cannot be recalled. Light doesn't have a break, but that's the long-term problem. The short-term problem is worse. Analysts reconstruct the probe's trajectories backward. Their approach vectors, combined with their deceleration profiles, point to a consistent origin, the same star system 12 light-years away. Their estimated cruise speed, roughly 10% the speed of light. That means they were launched approximately 120 years ago. 120 years, before your grandparents were born, before the first radio broadcast left Earth, before anyone on this planet knew what a radio wave was. They weren't responding to us. They were sent before they could have known we existed. These probes were launched toward a solar system that looked promising. A yellow dwarf star, a rocky planet in the habitable zone, liquid water on the surface. A candidate, one of thousands, perhaps millions of targets seeded across the galaxy by a civilization playing a very long game. Remember what you believed on level 4? That the signal was aimed at another civilization. That you had intercepted a conversation between two alien species. You were wrong. Your scientists were wrong. It was the only explanation that made sense at the time, because the alternative was too large to see. The signal was never a conversation. It was a command. A software update sent to dormant probes already approaching their targets across dozens of star systems. The primes, the binary, the molecular diagrams, not a curriculum, a calibration sequence. And the silence on level 5, the moment the signal stopped, wasn't destruction. It was completion. The update was finished. The mission had moved to its next phase. You look at the sky. The probes are still transmitting. The beacon pulses every 90 seconds. Somewhere out there, something is listening. The question is no longer whether we are alone. The question is what comes next. And that question is not yours to answer. It never was.